Hello, today we're going to talk about problem solving. As engineers, that is our main job, is to solve problems. So let's look at different techniques to solve a problem and maybe find a method that will work really well for solving problems. Employers really, again, hire engineers to solve problems, right? That is what we do as a job, right? And solving problems really is a learned skill. And we've been learning Excel this semester, and we'll continue to learn Excel. And that's really one of the tools or skills that we can learn to help us solve problems. We also can learn to solve problems by doing them. You'll find people in industry that have a lot of experience in something. It's because, and they can solve problems really well, it's because they've been doing it for a really long time. Engineers solve problems, of course, with your computers, but you must realize that the computer is only a tool. It is not a replacement for the engineer, but it is a tool that the engineer can use to help you solve problems. And there's a lot of different problems or tools that we can use as engineers. There's different types of testing equipment and all different types of things we can use that as engineers to solve problems. There's also a lot of different types of problems. One is like a research problem. In this type of situation, we have a hypothesis that we're trying to prove or disprove. We may have troubleshooting problems. I had a situation on a plant at Ford where on the manufacturing line where the machine was a vision system would keep giving me camera images of completely were white. And there seemed like there was something wrong with the camera. But it only happened every so often, and it seemed really not consistent, which is the worst type of problem when troubleshooting. You want a consistent problem. So it happened that we were there one day in winter, and in winter actually it was summer. I'm sorry, we were there in summer, and it was very hot in the building. If you've ever been in a manufacturing plant, they're very hot. They aren't air conditioned, and we were on the second floor watching the line run. And at this one particular moment, it was right around noon. It was very hot. There were these vents on the roof that opened up, and the light came in and shone specifically on that camera. We were able to solve that problem only because we were there at that specific time. It threw that car off the line, and we knew what the problem was, and then we could shield the camera from that light. Other types of problems you may have are mathematics problems. I'm sure you've seen those frequently, and we use those a lot in engineering to model physical situations. We might have resource problems. We talked about project management earlier. Sometimes there's resource issues as far as lack of staff or your staff isn't trained or not motivated. Maybe there's money issues, right? That's also another resource that we might have. Another one is social type problems or environmental type problems. You could have a situation as a civil engineer where there's a lot of accidents out on this highway where there's this curve in the road. And do you take the money and really straighten out that road? By doing so, you're going to be taking away some of the farmland that's been in this family's been in the family for many generations, right? So we've got these social issues maybe, and we have to weigh those out in what we do. But at the crux of everything is really design problems. That's where the heart of all of this really is. Engineers use the design cycle to solve design problems. Characteristics of a good problem solver. This is a list of all of them. I'm not really going to go through them, but there's one in the book too, if you read the book, that kind of always sticks out in my head, and it's this one here that is highlighted, this one that says attacks for a novice problem solver, attacks the problem all at once and tries to calculate the answer right away. Many of you may have already done that with your problem for the project itself. I highly encourage you to try and take the problem and break it into pieces and really try and understand it all before really just coming to a solution. This is a very characteristic thing that many people do. They go right to the solution without really fully understanding everything. And a lot of times that solution is not the one that you want. All right, one of the most common type of methods that we have in solving problems is this analytical problem solving method. And this is a tool that I want you to use. It can be like a type of a math problem or story type problem. And there's 6 steps to it. And the first step is always to restate the problem in your own words. Next is to have a description, list all of the givens, what is given for the problem, and then state what needs to be found. Third, we're going to list out the theory or state the equations that we need to solve the problem. Maybe we need to have some assumptions, make some assumptions. Not everything is given to us, and we need to state assumptions. And if we do that, maybe we need to state the source where we're getting our assumptions from and why we're making them. And then we actually go through and solve the problem. We perform our calculations. And then the last step is a very important step, is always to verify the accuracy of our solution, right? We can ask other people, we can look at other types of problems that are similar to it and see if it makes sense to us. So again, we could recheck our work. Does the answer really make sense for what we know? We could compare it again to similar solutions, estimate the answer itself, have someone else look over our work. If it's going to cost the company a lot of money or put someone's life at risk, we really definitely should have other people looking at our work. Here's an example of a format for homework that I will want you to do when you solve problems. This is called engineering computation paper. We'll talk about this in just a minute. And you have on the heading up here, it's kind of laid out like this. On the back side is some kind of graph paper. But you kind of put your name up here, the date, the class that you have it for, the problem number, what you're trying to find, what is given. You would write a solution, box in your answer, and then kind of make some commentary or verification. All right. So that's how you solve analytical problems. And we already talked about how to solve creative type problems, right? Problems that really need to be very creative, that aren't concrete or analytical, they're more subjective. And that's through, of course, our design process. These really help us solve open-ended type problems. The book also goes through another method of creative problem solving, and this is this whole convergence, divergence. It's on page 207. I'm not going to read through all of that right now. I'm going to give some final comments on what I want you to take out of this, the big part besides the design process and the convergence, divergence, which you can read in the book. It's again this technique for solving analytical type problems. We need to organize our known information, draw a picture, state what is given, state any assumptions if they're needed, state what we need to find, list all the properties and data along with the units, what we're going to find, identify and label the required unknowns, set up any relationships or list any appropriate equations, rearrange the equations if we need to, and solve for any of the unknowns, and identify and add any subordinate equations that are needed. Finally, you're going to work out the solution itself, so you'll do all the algebraic manipulations, any substitutions, whatever it might be, and then we'll do a unit check to make sure everything is correct, and then we'll compute our answer and also clearly mark our answer by boxing it in, right, and check to make sure that our answer makes sense and agrees with our estimate, right? This is our verification part. Go make sure that you've answered all of the questions. All right, so this is the problem solving technique. In the next video, we'll actually go through an example using this analytic technique. We've already done the creative part using the design process. You're already doing that with your project.